The position of an object is plotted in this graph versus time. In this motion, it's obvious that the whole motion is non-uniform. However, the motion from time 0 to 2 seconds is uniform, this straight line. And there is another motion which is different from the first one, from time t equal 2 seconds to 4. From time 4 seconds to 5 seconds, the object is obviously stationary, it's not moving. And then another motion from time 5 seconds up to 7 seconds. And the final motion is from 7 seconds to 8. In this problem, you are asked to find the average velocity at different intervals. To solve the problem, write the formula for the average velocity equal to delta x over delta t. That is x final minus x initial divided by the time interval t final minus t initial. Then what we need to do is to find the initial position that corresponds to the initial time t equals 0. Here for t equals 0, obviously x initial is 0 as the motion starts at the origin. And then we find at t final with 2 seconds, the position equals, the corresponding position equals 10 meters. Then by applying the formula and substituting the x final for 10 and the x initial for 0, that corresponds to the time interval 2 minus 0, then the result is 5 meters per second. The positive sign here indicates that the average velocity is directed towards east. For part B of the problem, it's required to find the average velocity from time t equals 0 to 4 seconds. To do that, we have to find the initial position, which is equal to 0, that corresponds to the initial time of 0. The final position is 5 meters, that corresponds to the t final 4 seconds. Again, applying the formula, substituting the x final and x initial and the t final and t initial in the formula to get positive 1.25 meters per second. That is obviously the direction of the east for the average velocity in this part of the problem. The average velocity from time equal 2 seconds to 4 seconds is required in part C. So the initial position for the initial time is 10 meters, while that for the final time is 5 meters. Again, apply the formula of the average velocity. You're going to get 5 minus 10 over 4 minus 2. That is minus 2.5 meters per second. The negative sign here indicates that the average velocity is due west. In part T, for the initial time 4 seconds, you have a corresponding position of 5 meters, and for the final time 7 seconds, you get a corresponding position of minus 5. Now apply the formula. The final position is minus 5 minus the initial position 5, that's minus 10, divided by 7 minus 4, that's 3. So minus 10 over 3, you're going to get minus 3.33. Again, we have a negative sign, and this is referring to the direction due west. And finally, to find the average velocity between time t equals 0 to time 8 seconds. Now, the initial and final position are obviously having the same value, 0. So, and the result is obviously going to be 0 for this part of the problem. For the same plot of position versus time of our previous example, a student is asked to solve this problem at different time intervals. The first from t initial equal 4 to 5 seconds, and the second part is from 5 seconds to 7, and the last one from 7 to 8. I would like to give some tips on that. It's obvious for the time interval between 4 and 5 seconds that the object is not moving, so it is expected to get an answer of 0. However, for the interval from 5 seconds to 7 seconds, the slope here is negative, so it is also expected to get an answer of negative sign, and this means that the direction is expected to be to the west, while the last one for 7 to 8 seconds, the slope is positive, so the average velocity is going to be positive.